I'm Brian Issa. A warm Namibian welcome to all advanced subsidiary level mathematics learners and everybody else interested in learning maths. This is the second video lesson in a series of 5. Well, today we are going to show you how to apply factor theorem to polynomials. We have one learning outcome for this lesson, and that is to help you apply the factor theorem to polynomials. Ready? Pens out, notebooks open, here we go. Firstly, some basics. Remember that a factor of a number is a number which divides into it exactly without leaving a remainder. The factors of 12 are 1, 2, 3, 4, 6, and 12. A factor of a polynomial is an expression which divides into the polynomial exactly without leaving a remainder. What is the factor theorem? We can use the factor theorem to find out whether the divisor is a factor of the dividend or not. The factor theorem states that ax plus k is a factor of a polynomial f of x if and only if f of negative k over a equals to 0. I'll give you a moment to write this down so that you can keep referring back to this rule. Now I think we are ready for an example. This is the way they might ask the question. Determine whether x plus 2 is a factor of x cubed plus 3x squared plus 5x plus 6. Don't worry, we'll do it step by step together. First, we have to work out the value of x in the divisor by setting it equal to 0. Then we'll substitute the value into the dividend to see if the answer is 0. Ready? If x plus 2 is equals to 0, then in order to get x, we have to minus 2 on both sides. We see that the value of x is negative 2. Now all that remains is to substitute negative 2 for every x in the expression. This is easy. F of x is equals to x cubed plus 3x squared plus 5x plus 6. Now becomes f of negative 2 is equals to negative 2 cubed plus 3 times negative 2 squared plus 5 times negative 2 plus 6. And we can easily work it out. The calculation of negative 8 plus 12 minus 10 plus 6 gives 0. Yes, the answer is 0. This means that x plus 2 is indeed a factor of x cubed plus 3x squared plus 5x plus 6. It would divide exactly. Yo, first one done. Let's do example 2. This time we are asked to show that 2x minus 3 is a factor of 2x cubed minus 9x squared plus x plus 12. Do you remember step 1? Set 2x minus 3 equals to 0 and see what the value of x is. Let's do this. Solve 2x minus 3 equals to 0. We find that 2x minus 3 is equals to 0 and 2x is equals to 3 and x is 3 over 2. Now it is simply a matter of substituting 3 over 2 for every x in the function. In other words, f of x is equals to 2x cubed minus 9x squared plus x plus 12 becomes f of 3 over 2 is equals to 2 times 3 over 2 cubed minus 9 times 3 over 2 squared plus 3 over 2 plus 12. Use your calculator to calculate this. The answer is 0. What does an answer of 0 tell us? We now know that the remainder is 0, which means that the divisor of 2x minus 3 is a factor. Now we have shown as per the instruction that 2x minus 3 is a factor of 2x cubed minus 9x squared plus x plus 12. Well done. Let's now do example 3. Find the remainder when f of x is equals to x cubed minus x squared plus x minus 1 is divided by 2x plus 1. This is just another way of doing what we did before. We have to make the divisor 2x plus 1 equals to 0. Then find the value of x. So 2x plus 1 is equals to 0, which means that we can deduct 1 on either side and divide by 2 on either side, and we find x equals to negative half. You know what to do next, don't you? We substitute negative half for every x in the given expression. F of x is equals to x cubed minus x squared plus x minus 1, like this. F of negative half is equals to negative half cubed minus negative half squared plus negative half minus 1. Now we start calculating with our calculator and find the result is negative 15 over 8. This means the remainder which was asked for is negative 15 over 8. Did you follow? Learners, we are now going to do one last example, this time a little bit more difficult, but the method remains the same, so don't despair, please stay with me. We are given this function, f of x is equals to 2x cubed minus 5x squared plus ax plus a. Now they are asking, given that x plus 2 is a factor of f of x, find the value of the constant a. Learners, what should you remember? Don't freeze up. You just go with the same steps. They told us that the divisor is x plus 2, so equate it to 0. X plus 2 is equals to 0. Now solve for x. We get x is equals to negative 2. So far, this is not really harder to understand. We know that x plus 2 is a factor of f of x, so that means f of negative 2 is equals to 0. Again, we simply replace every x with negative 2. F of x is equals to 2x cubed minus 5x squared plus ax plus a becomes 2 times negative 2 cubed minus 5 times negative 2 squared plus a times negative 2 plus a equals to 0. And this is an equation which we can solve. 2 times negative 8 minus 5 times 4 minus 2a plus a is equals to 0. And then negative 16 minus 20 minus 2a plus a is equals to 0. So that negative 36 minus a is equals to 0. And now we get negative a is equals to 36. But we don't want negative a, but a. So a is equals to negative 36. Go back to what was asked, which was find the value of constant a. The value is a is equals to negative 36. Guess what? We have done it. We are through the day's work. Well done, learners. Viewers, thank you for watching our video today. I hope it will make you feel more confident about the factor theorem. We have seen in today's lesson that the factor theorem says that ax plus k is a factor of the polynomial f of x if and only if f of negative k over a is equals to 0. This means there is no remainder. The proof of understanding lies in practicing until it becomes easy. I hope you join me again next time. Until then, goodbye.